In question 3, so we have a diagram. Figure 1 shows a sector AOB of a circle with center O and radius R. The angle AOB is theta radians, and the area of the sector AOB is 11 centimeters squared. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of R. So the formulae we need to remember here. So for a sector, the arc length is R theta, and the area is half R squared theta. That's very crucial as long as it's measured in radians, your angle, which is true in this case. So we're going to use these to create some equations and solve this question to find R. So let's make an equation with the area being 11. So this implies that half R squared theta is equal to 11. So we could times everything by 2, so R squared theta is equal to 22. So I'm going to bank that as an equation. We also know that the perimeter is 4 times the length of the arc. So the perimeter is R, and the arc length. So the perimeter would be equal to 2R plus the arc length, which is R theta. The arc length itself will be R theta. So it says the perimeter is 4 times the arc length. So we can make an equation. So 2R plus R theta must be the same as 4 multiplied by the arc length, so 4R theta. So from this, we can say that 2R is equal to 3R theta. We can actually cancel out the R's here, and we get that theta is equal to 2/3. So let's remind ourselves, so we earlier established that R squared theta is equal to 22, and we now know that theta is equal to 2/3. So that means that 2/3 of R squared is equal to 22. So if I multiply that by 3, 66 divided by 2, we get R squared is equal to 33, which implies that R as an exact value is the square root of 33. And that's the answer to question 3.